Let me set things straight. I do not recommend capacity estimates in interviews. This applies both to interviewers and to the candidates, more so to the candidates, for a number of reasons. First, I don't believe in them much, to be honest. It's far more important for the interviewer to see how the candidates reasons about scalability and availability compared to how well can they do back of the envelope math. And another reason to be careful with estimates if you are a candidate is that you don't really get bonus points if you do them correctly. But if you're off by an order of magnitude, this could be held against you by the interviewer. So honestly, it's in your best interest to not go into specific numbers. Before phrasing questions or guesses about the numbers of users, requests, etc., my high-level recommendation is to frame the interviewer so that they realize you understand that your system would need to be distributed. To illustrate this, let me frame you first. Then I'll suggest ways for you to navigate this conversation effectively. Why do we look at the numbers? The two key reasons are scalability and availability. Scalability. Eventually, one machine would not be enough. Presumably, you join a company after this interview, you're growing, and you outgrow one machine. That's normal, that's healthy, that's a good thing. You don't want your users to struggle while you're trying to frantically figure out how to add more machines. That's why you design your system to be scalable. That's it. For availability, because stuff breaks. Machines go offline, data centers get unpowered, internet gets cut off somewhere by accident or not. And ideally, for a real world, large-scale system, you really want to be able to sleep through the night, even if half the internet is down. You want to be able to be happily asleep, knowing your service is up and running. That's clear and trivial, right? I would add the third piece. Sharding, commonly referred to as horizontal scaling. If you can add capacity to your service by adding more and more nodes, as in shards, that's horizontal scaling. Because if you visualize it, you kind of add these nodes on the sides. The opposite of horizontal scaling, the opposite of sharding, would be vertical scaling, which is like using more expensive, cheaper, more powerful machines. But because of the Moore's law, you can't really pay 1000x money and get 1000x more powerful single CPU machine. It's just not possible, at least in the current architectural paradigm of processors and with our current understanding of the laws of physics, most notably the speed of light. That's why we need to build systems that are distributed. And that's why we interview you guys on sysdesign, because we will need you to prove to us that you know how to build distributed systems. Sorry for the detour, it was important. So now back to sharding after scalability and availability. If your system operates on bits and pieces that are disconnected from each other, you are perfectly scalable horizontally. You just add replicas, right? You add more machines, they take some load, and you're done. It's not as trivial. You would need to configure load balancing, you would need to work on availability zones and locations, but it's really not hard. You would need to make sure your database is replicated correctly across locations. That's doable. For a counterexample, consider a messenger service with large group chats, 100K people chats, or consider hotel bookings. In this case, the users, or in this more like the requests to your service, are interconnected. They depend on one another. In the case of, for example, hotel bookings, different users effectively compete for the same resource. That's the tricky part. In terms of sysdesign, that's where bad things happen. That's where non-trivial solutions emerge. We're talking about the online judge, where everything is absolutely parallelized. Your problems, your solutions, your submissions can be run by any machine anywhere on the planet. And if 100, 1,000, or 1,000,000 people are using your service concurrently, you just add more runners and you're done. So my point is, once you understand this, and honestly, it's not hard to understand, it really doesn't matter what's the number you put there. So back to the interview. Everything the candidate is saying makes sense. There might be a single order of magnitude error in arithmetic. I'm going to ignore it. Also, a good comment about spikes. Somewhat better way to phrase it would be to estimate the average load and then multiply it by a coefficient, claiming that, hey, at peak time we can be 30-40% above the average. That's just easier to follow, but details. The important part is that in order to design a good system, you don't really have to put in the correct numbers. I know I'm going in circles, but it's important. I'm not suggesting you should just dish the numbers entirely. If they help you pass the interview, if they help you be confident, by all means do it. If the interviewer is following a script and they need precise numbers, well, make something up. But I promise some exactly what to say coaching. Here it comes. In this case, though, it's not what to say, it's how to say it. I recommend phrasing capacity estimate figures as subtle clues, not something to obsess about, so that if you're off by an order of magnitude or even two, it won't hurt you. So the way to do it is you try to not emphasize the number itself. You try to talk about the whole thing, where the number is just a small part of it. Even if your interviewer disagrees with the number, and sometimes they do, you would have framed the design, the question, the topic, so that if they want to pick on that, they wouldn't ask about the number if they're a good interviewer. They would ask about a high-level design.